Welcome to Dr. T's Math. In this video I'm going to demonstrate how to use the TI series calculator to calculate a binomial distribution function formula, otherwise known as a Bernoulli trial probability, named after the famous mathematician Bernoulli, for all you history guys on there, guys and gals. So we've got a fair coin. Usually we're talking about dice and coins and stuff like that for general probability, because other events are just hard to estimate a probability for, whereas casino games give us the great opportunity of having discrete probabilities where they don't exist so often in real life. So we've got a fair coin that's tossed 10 times. We want to know what's the probability of getting exactly 4 heads. Well, we're going to use this here formula, binomial distribution, where this is the combination. You might know it as NCR, but it's also NR, written like that. If you get into a college course, you'll probably see it like that more often. And then that's going to be times the probability of success. In this case, success and failure are the same. Heads and tails are 50-50. Probability of success raised to the number of successes times the probability of failure raised to the number of failures. And so this is fairly straightforward, where we've got 10 factorial over 6 factorial, 4 factorial, times 0.5 raised to the 4th, times 0.5 raised to the 6th. And for this, we're still going to need a calculator. I mean, we could sit here and do all the calculations, but it's a bit tedious. And so I'll go the long way on the factorials just to kind of demonstrate. Looking at math, probability number 4 factorial, and I'm divide that by 6 factorial and 4 factorial. Remember in our previous video, the combinations yield fewer possibilities than permutations because order mattered. And so I'm getting 210 right there. Just to confirm 10, we're going to choose from that 4, and that's going to be 210, same result. So we're going to take that number and multiply it by 0.5 raised, where is it? Where's the little caret? Raised to the 4th, and then arrow to the right to get out of the exponent, and then again times 0.5 raised to the 6th, and what do we get? 105 over 512, or about a 21% chance of getting exactly 4 heads, which is kind of interesting because if we had 10 choose 5 times 0.5 to the 5th times arrow over 0.5 to the 5th, then, no, let's do it again, 10, choose 5, no, not P, 10, try one more time, 10, choose 5, it gives us 252, we're going to multiply that by 0.5 raised to the 5th, so success 5 times, and then multiplied by, again, failure 5 times. And that's 24% chance. The surprise there is that we would assume, you might automatically assume that there's going to be a 50-50 chance. What are you talking about? Well, we'll get to that in the next slide, but this is exactly 4 heads, right? So the probability of getting exactly any one number of heads is kind of small. So instead of doing all that mathematics stuff with all the remember and the formula and, you know, inputting times and chooses and stuff by hand, let's look at a faster, easier way, since that's what the calculator is for. So we're going to go second vars, and it gives us this big menu. Going down to letter A, which is a binomial probability. And it says number of trials, P and X. Number of trials in this case is 10, the P is 0.5, and then the X is going to be 4. So we're going to get 10, comma, 0.5, comma, 4. And it's going to give us the same number, about 21%, as we saw in the previous outcome there. So that is about 0.205 equals 0.205. Remember, probabilities are always between 0 and 1 because you have between a 0 and 100% chance of getting some outcome. There's going to be an outcome no matter what. There's always an outcome. Even if that outcome is nothing in some situation, that is an outcome. And so that probability of something happening is always 100%. Something's going to happen, even if it's nothing. So in this case, let's look at the probability of it getting at least 4 hits. So we're looking at less than or equal to k. In this case, x is going to be like the number of successes, and then k is going to be 4. And then we're going to have to add all these things up. So what that's going to look like is we've got 10. We're going to see the probability of exactly one heads showing up. And then we're going to add that to the probability of exactly 2 heads. And this is the real long, tedious part. If you're in a college level probability course, you'll have to remember these formulas, and then you're probably going to have to sit and do all this stuff by hand, and your teacher will say, well, that is reinforcing the process or whatever, which is true. However, that's not exactly what most students are into. And so then we get calculators that are doing it for us, which is definitely more satisfactory to most students. And so that's what it's going to look like. We're just going to have to add up, the probability of getting exactly 1, plus the probability of getting exactly 2, plus the probability of getting exactly 3, plus the probability of getting exactly 4. And we already proven that the binomial PDF function is a shorthand fast track to what's the probability of getting some exact result. So let's just go to that instead of sitting here and doing all of the long arithmetic. I'm going to add up, I'm going to do a little bit of arithmetic, but I'm going to do the binomial number of trials, 10, and our probability of success is still 0.5, and then we're looking at 1. I'm going to add to that the probability density function, binomial probability of 10, 0.5, 2, and then add to that for 3 and that for 4. And this is still taking a little bit more time than the other thing, which I'll show you in just a moment. But it's certainly faster than doing NCR 0.5 to the first times 0.5 to the 9th, and so on and so forth. So we did this 4 times, and it's just fewer commands than if we did it all in the original form. And 4 is our final one. So what we get here is 0.375. There's a 0.375, or like a 37.5% chance of getting at least 4. So 1, 2, 3, or 4. But then let's do it faster than that even. We're going to go down to letter B, binomial CDF, binomial cumulative density. And still the same thing, number of trials, probability of success, and the number of desired outcomes that are success. Right, so we got 10.5 and 4. And bam, it gives us a slightly different number. Would you look at that? And that's going to be what? 0.376, 0.376. If you round, you'd have to round that binomial. Did I do something wrong? Well, that's interesting. That's really, really interesting. Oh, and do I have to do 0? How about, what's the probability of 0? I forgot 0. So let's take 385. It's 385 divided by 1024. Divided by 1024. Put that in parentheses. And we're going to add to that the probability of 0 heads, I forgot, plus, and it's going to be a really low probability, plus binomial PDF 10, 0.5, 0, and lo and behold, it's the same number. So don't forget your zeros, but you don't have to do that because you got binomial CDF. And so this is approximately 38%, roughly. Okay, so probability is the part over the whole. It's the number of successes divided by the total number of possible outcomes. And in this case, the calculator is just making it a lot faster. So this has been Dr. D's Math. Thanks for watching.